Okay, this is where the connectors are. Some of the connectors I'm going to replace. I've already unplugged them. Here they are right here. Yeah. Now this one doesn't look too bad, except on this side. See, it's a little burned. This one's a mess. I mean, look, it's cracked, it's broken, the pin's falling off of it. There's burn marks. This one's so that one's a mess. But this board was probably not meant for please don't. Okay, there's these 3 bolts right here that I have to unscrew, and there's these little standoffs here. Those are little rubber parts that hold the circuit board in place.
Man, somebody did not want to take this apart.
You know, they probably didn't expect the machine to, you know, last long enough to really need repairs on this part, because this is probably one of the simplest things on the machine. It's just a board with a few like resistors and I think this is a capacitor or something, and fuses. So this is one of the simpler parts of the machine, and you know, the mechanical stuff would probably is more likely to fail long before this does. Okay, my thing with the pliers wasn't working, so I'm going to actually use the proper tool. What a concept! Okay, either this arcade was the site of like a fire or something, or more likely, some idiot before us attempted to repair this thing and failed miserably. I mean, look at this. I don't know how this thing would even be. Well, I wouldn't go that far, but what the heck is this stuff? I mean, seriously, what the heck is it? And look right there, I mean, it looks all burned. I mean, how the heck did that even happen? It's on the opposite side of the connectors. And look at the wires. Gosh, what did someone like take a match and like drop it between the board and the metal part behind it? Alright, so we've soldered on a new connector pin header right here. That one that's black right there is the one we replaced. This one is also going to be replaced as well. I also unscrewed the transformer because it's attached to these things, but the only thing attaching the board, there's no other wires running to the transformer other than the ones going in the board, so that's fine. Okay. Okay, I've got about half of this 20-pin connector disconnected. It's actually 2 10-pin connectors joined together. This is the bridge rectifier board. It uses 0.156 connectors, if that's of any interest to you. By the way, 0.156 refers to the amount of space between the actual pins, not the diameter of the pins themselves, as I originally thought. They're actually like, so there's 0.156 inches of space between the pins on these connectors. So the next step is to pin in these new connectors. Now let's get one right here for, oh, whoops, that's not part of the machine. At least I hope it's not. Here's the old one. Wow, there's only 4 of the 8 pins are actually connected to anything. Now there is one pin that would have to be missing, and that's the polarizing pin. That prevents you from plugging it in the wrong way. The reason I'm replacing it is because some of the lights have been flickering on this thing, and I've noticed that some of these connectors were kind of looking a little burn looking. I don't know if you can see this, but there's a little brown spot there. Not to mention that this connector up here, when it played, the game would run for like 10 minutes and that thing would be too hot to touch. So if this thing were on location, it probably would have burned the place down by now. Okay, so next thing is then I'm going to repin them. I'm going to repin new wires. As long as I can find the... Oh, yeah, here they are. Here's the actual female connector pins that go into this part. Oh. And now I shall take my magical crystal ball. Oh, magic silver ball. I wish for this connector to repin itself. Alright, so I've gotten this connector repinned, and what happened? Ah, darn it, the stupid wishing ball hurt my fingers. And it ripped this connector apart. I knew I shouldn't have bought those magical items on sale. Anyway, I've got about half of these things on the 20-pin connector on the bottom crimped back on. So I'm gonna go ahead and do some of them. I'm gonna go ahead and do the rest of them, and then put them back into a new connector housing. Okay, so the proper procedure for repinning for attaching a new connector pin to a wire. This is, by the way, is a .156 connector. So you have this special crimping tool, and there's then you strip the wire to about that long. You want there to be enough so that there's enough insulation to. You want there to be enough to kind of go in and then just. That was me. And voila. So the outer part should kind of bite into the insulation of the wire, and the part up here, which is closer to the actual connection pin, should bite into the actual wires, the conductor part. So you want to get it in between here so that both the larger pin and the smaller pin can get will get pressed down by this top part. Okay, so we've finished repinning all the connectors. We're just gonna put them right in this plug now. Put them into here. Now, I've written down the numbers of, what color goes to which pin on the connector, so this should be relatively straightforward. First one is green, the second one is sort of a white color, and some of the wires have stripes on them too. So overall this should be pretty simple. Okay, we've got the connectors all connected. So now all we gotta do is, man, this thing's heavy. We gotta reattach these things to their proper place and then plug the connectors in. Okay, first thing we gotta do is screw the transformer back down. And then we just gotta put this part back on and put little bolts on in the middle, and you guys already saw how we did that. That's a really nice place to put the cord, by the way. They really thought this thing through when they decided where to put the attachment point for the cord.
If you don't know where it is, it's right here.
Yeah.
That red dot right there.
Yeah. Look how much room you've got to work in.
Seriously, I'm short and little.
It's so easy
I can't.
It's so easy to reach. All you need is like a little man who's about 2 inches tall to do it for you. Really, why would they put it there? Why couldn't they put it inside the back box or something?
Even I would hit my head working on this.
Yeah.
And if you haven't seen me, I'm short.
And I'll show you the other way the playfield could be set up, but it doesn't really make it much easier. This is the other way the playfield could be propped up backwards, but then that really doesn't make it any easier to access. So,
as you can see, we can't even see it from here.
Yeah. So, in fact, I don't know how they even expected anyone to be able to access that.
Maybe they didn't.
Yeah, really. Okay, we're now going to unsolder the cord from the little metal box. Okay, so as you can see, we've gotten like all the connectors repinned, those lights are working again, but there's still a few things that need attention. Those lights up there, those should all be on whenever the target that they correspond to is up. As you can see, only 2 of them are working. Probably just burned out bulbs. Some of them might need a socket cleaning or something like that. But there's one little problem with the left flipper. I don't know if you can see that, but it keeps causing the left slingshot to go off. And it's not because of switches or vibration, it's because of some kind of power surge caused by the motor, which doesn't happen with the other flippers. And I'm pretty sure that that's a bad diode. You can also hear a popping noise from the speaker. If you have one coil that's causing a power surge that appears to be causing some kind of malfunction, but the other coils don't do that, it's most likely a bad diode. Those are really cheap to replace, and continuing to operate the game with a bad diode can actually be bad for the machine in the long run, like with the circuit boards and stuff. And I don't know, but the power supply maybe, I don't know. But I don't want to find out, so I'm going to replace both of the diodes on the flipper. A flipper coil has 2 diodes, one for the high power side, which is the one that like makes it move, and one for the low power side, which holds it in place. So I'm going to replace that diode, which is going to require a soldering iron. So I'll just turn this thing off. I'm going to unplug it, and I'm going to lift up the playfield and work on that. Okay, there's the flipper coil. You're probably wondering, you said there were diodes, but where are they? They're on the other side. See how there's 2 of them? And I'm pretty sure that one of them is bad, because this is the only flipper that causes the game to malfunction. And that left slingshot firing, that's not the only thing that this thing has caused. It's caused the game to reset, it's caused the game to tilt, or just completely crash sometimes. Okay, so I've gotten that one flipper working again. I put new diodes on it. I did have a little problem with it though. When I was soldering it, I didn't use as good enough of a heat sink the first time around, so I ended up breaking one of the diodes, and I didn't realize it because it didn't appear to be damaged, but it was. So anyway, what happened is that every time I would press the flipper button, it would blow the fuse. And I thought that maybe the motor had just burned out or something, whether as a result of something I did or just a coincidence because the thing's like 30 years old. Okay, the other thing I want to do is try and fix that screen there. It's misbehaving. I think it's a connector issue because usually I can get it back to normal temporarily by unplugging and replugging the connectors. So I'm going to be checking to see if, the solder's messed up or anything, or, because usually I can get it to work again by tapping it, at least, kind of. Yeah, so I'm guessing it's a bad solder joint on the connectors, or the connector plug needs to be replaced. Okay, so we've removed the display here. As you can see, not terribly complicated. The machine was unplugged, by the way, while I was doing this, but I'm going to have to unsolder that and solder on new header pins. Okay, here's something that I've talked about but I haven't actually shown yet. You see this light socket? This socket doesn't, is kind of intermittent at times. And I've read that, that sometimes the connection between this and to this little nib right here can sometimes become marginal and cause the light to be dim or flicker in and out or just not work at all. So one solution is to actually unsolder the wire from this pin and solder it directly to that little nib right there. Now you may be wondering, if you're gonna have to solder to do this anyway, then why bother? Why not just replace the socket? Well, for this socket that would probably be a good solution, but for these, that's not quite as practical. See, the sockets are attached to these boards and they can't really be removed. And the thing is, I've never been able to find these mounting strips or light strip boards or whatever they're called. I've never been able to find them. I mean, I've never even found used versions of these for on sale anywhere, so I don't know. So I mean, for this little socket it'll be fine, but by the way, this trick only works if the socket has a solid nib like this. It won't work on a socket that has an exposed spring on the bottom like that one right there. Although I believe this type of socket is relatively standard, so that shouldn't be a problem. See, there's another one of them right there in a better position. Now this little nib probably isn't going to be solderable until you file it or sand it. So that's what we're doing right here. Because over the years they can get kind of a layer of oxidation, which you probably won't be able to really see. You'll definitely, once you're done filing, you'll definitely be able to tell the difference between one that's been filed and one that hasn't been. So it looks a little different now. Right now it looks all scratched up, but that doesn't matter because it's on the inside of the machine anyway, and we're going to solder over it. And anyway, we'll take our 25-watt soldering iron, being careful not to burn the insulation of any surrounding wires. That's just me emptying the unsoldering pump. And then we'll take this wire right here, it's now unsoldered. We'll bend it to a position where it'll kind of rest on there. In some cases you might want to use cable ties, or I don't know. Once it's soldered and the solder's cooled, you shouldn't have to worry about where it's sitting. But you want it to be in a position where when you let go of it, it won't like it. You want to have it in a position where it wants to rest on the nib. If not, then it'll come off before the solder is cooled and dried. So now we're going to solder it. You want to give it a little bit of heat. Apply it to the top of the wire and wait a few seconds. And then get a little bit of solder in there. It'll start to melt. This is lead-free solder, so it might behave different. So if you're using traditional solder that's lead-based, it might behave a little differently, but in any case, but it shouldn't be that different. And now I'm going to wait a few seconds and for the solder to cool, and then I'm going to gently tug on the wire, and it's secure. So now the only thing left to do is test it. I'm now going to plug the machine back in. And I'm going to turn her on. And as you can see, the light is now working. If you have a light that's intermittent, contrary to what you might think, it's actually possible for a bad light bulb to be intermittent. I never knew this was, I never thought that was possible, honestly.